This is just a quick review of how to name ionic compounds, covalent compounds, and acid and bases before your test. Feel free to watch this video as many times as you need to before your test. That way you can get a little extra practice in. Okay, first we'll start out with some binary ionics. If it's binary, that just means that the anion is just a single atom, so it might be like a phosphide or a chloride or sulfide, something like that. So in this example, we have Na, which is sodium, and then P, which in this case would be phosphide because we're talking about anions. So sodium has a charge of +1, and then the phosphide has a 3- charge. So now that we know our two charges, all we have to do now is cross them. So then the 3 will come over here. The 1 will come over to the right side. Now that we have that done, now all we have to do is just bring down our elements. So we have our sodium. We're going to bring that down so it's just Na. The 3 comes with it. It's a horrible 3. Now we have our P. That comes down. We don't write ones in chemistry, so we leave it as is. And our final formula would be Na3P for sodium phosphide. Okay, next we'll talk about polyatomic ionic compounds. The polyatomic anions are the ones that are on your anion sheet and the ones that I hope you memorized before your test. Again, just like with your binaries, you need to cross your charges with those. Polyatomic's the same thing. It is very, very important that you cross your charges. This stuff will not work out for you if you do not cross your charges. That is extremely, extremely important. I cannot stress it enough. So in our first example, we have calcium bicarbonate. So the first thing we need to do is determine what calcium is. Calcium is Ca, and it has a 2+ charge. Bicarbonate is one of the ones on your anion list. The formula for that one is HCO3, and that has a -1 charge. So again, if we cross our charges, the 1 from bicarbonate comes over to the right. It's a pretty bad 1. And then the 2 from calcium comes over from the left to the right. So now that we've crossed our charges, again, just like with my previous example, all we need to do now is just bring down our elements. So we have Ca. Again, we don't write ones. Then we have our bicarbonate, which is a group, and we need to put this 2 on it. Anytime we need to add a number to a group, that entire group is going to be in parentheses, and the number goes on the outside. So we have our Ca, then our bicarbonate will be in parentheses, and the 2 goes on the outside. And that would be our final answer. Again, if we are adding a number to a group, the entire group needs to be in parentheses, and then the number goes on the outside. Okay, next one we will do will be Ni3PO4 in parentheses with the 2 on the outside. So now this time, instead of writing the formula is already given to us, so we need to write the name. So Ni is nickel. So we can start out writing nickel. That was a horrible K. Okay, and we know PO4 is phosphate. Now PO4 has a 3 charge, a 3- charge. So when you have a formula like this, it's almost like the charges are already crossed. So this 3 came from the PO4 to the nickel. And that means the 2 from the nickel came over to the PO4. So nickel is a transition metal, which means that it always needs to have Roman numerals. The Roman numeral tells you what the charge is on the transition metal. So since these charges have already been crossed, if we were to uncross them, again, the 3 from the PO4 went to the nickel, and the 2 from the nickel went to the PO4. So if that 2 came from the nickel, then that tells us that this is nickel 2, and then we just add the phosphate. And that would be our final answer for that one. So again, if it is a transition metal, please make sure that you have the Roman numeral. That is extremely important. We've already discussed that it is wrong if there is no Roman numeral. And also, if there are no parentheses where there should be parentheses, that is also wrong. So please be careful of what you are writing before you turn it in. Okay, next thing we're going to talk about is covalent and molecular naming. Covalent and molecular compounds are the same thing. It's just a different way to say it. Okay, big thing with these, how you tell these apart from the other ones, is that these are all nonmetals. There are no metals in a covalent or molecular compound. If you see a metal, it is automatically ionic. So again, please remember, these are all nonmetals. Also, the prefixes are needed for this, so that's all the mono and tetra and things like that. Those are necessary. These do not use the Roman numerals. We do not need Roman numerals for these because there are no metals. Roman numerals are only for transition metals, so if there are no metals, then there are no Roman numerals. It's very simple. So please keep those things in mind also when you are writing some of these. Okay, so our first example, we have dinitrogen pentasulfide. This is where knowing your prefixes comes in. So we know that nitrogen is, of course, N. If it's di, the prefix for di is 2. So that would be 2 nitrogens. And then we know sulfide isn't just an S. Penta is 5. Think of like the Pentagon in Washington, it has 5 sides. So anything penta is 5. So if it's pentasulfide, that means there's 5 sulfides. And that would be our final answer for that one. So that's dinitrogen with the 2 nitrogens and then the 5 with the sulfide, pentasulfide. Our next example is CO. Now this time you've been given the formula, you need to tell me the name. Very simple. C is carbon. We only have 1 oxygen here. The prefix for 1 is mono, so that would be monoxide. So then our final answer is carbon monoxide. So again, the take-home message with the covalent and moleculars, they're all nonmetals. Nitrogen is a nonmetal, so is sulfur, so is carbon, so is oxygen. These are all nonmetals. There is not a metal in sight. If you see a metal in the compound or if the name has a metal in it, it is automatically an ionic compound. So covalent compounds, you do need the prefixes. That's why we have dinitrogen, monoxide. And there are no Roman numerals, as you can see. Okay, and the last thing we'll go over is how to name the acids and bases. This is the newest thing that you all learn to do. So we'll do the acids first, and we'll talk about the bases. When we did this, I gave you 3 rules for naming the acids. First rule I gave you was that if the ion, well, the anion, excuse me, ends in "ide," so if that was a chloride or a bromide or iodide, anything like that, it's going to be something, it's going to be hydro, then something ic acid. So this one, ide, goes with hydro, and then something ic acid. This is the only one that will be a hydro. The rest of them will not have hydro in it. So if it is a sulfate or something like that and you put hydro, whatever sulfate, it's wrong. There is only hydro when you're dealing with something that ends in an "ide." That being said, if it ends in "ate," "ate" and "ic" go together. So if it's a sulfate or a bromate, chromate, anything like that, it will be something "ic" acid. You will drop the "ate" and add "ic" for "ic." "Ite," "ite," goes with an "us" acid. So like if it's a sulfite or a chloride or nitrite, anything like that, you'll drop the "ite" from the name and add the "ous" acid. A good mnemonic device for this, what we ate was "icky," because "ate" and "ick" go together, but it was "ite" with "us." I know that is horrible grammar. Please do not tell your English teacher that I taught you that, but it'll help you remember. So again, what we ate was "icky," but it was "ite" with "us." And then, of course, again, "ide" is just hydro something "ic" acid. Okay, so in our first example, we have HOCN. This is where knowing your anions comes in handy. All acids will begin with an H. So how we know what we need to name it is based on the anion, which in this case is OCN. OCN is cyanate, not cyanide, but it is cyanate with an ATE. So if OCN is cyanate, then the acid name that it's going to go with is going to be an "ic." So the name of this acid, if we were to follow the rule, if it's an 8, it's going to be an "ic" acid. So that means we would get rid of this 8 and replace it with an "ic." So the name of this acid would be cyanic acid. Our next example is sulfurous acid. Notice that this ends in an OUS. We've already said that OUS and "ite" go together. So that means that whatever this anion is that it came from for us to write the formula is going to end in "ite." So if we wanted to know what it was, we would simply get rid of that OUS and we're going to replace it with "ite." So we know that the acid name is going to start with an H because they all start with H. Again, if we replace that OUS with an "ite," that's going to be a sulfite. So then the formula for this would be, well, excuse me, sulfite is SO3, and it has a 2- charge. So if we were to cross our charges with the H and that 2-, we'll end up with H2 and then SO3. So that would be our formula for sulfurous acid. So again, these acid naming rules are very important. Please make sure that you go over those again if you haven't already. Moving on to bases. Naming bases is the same thing that you guys were doing with the ionic compound naming, so this should not be that difficult or that different for you. Again, with the bases and just anything else except for the covalent compounds, you must cross your charges. If you do not cross your charges, you will have a problem when you are trying to write the formula and figure out what the name is. Please make sure that you always remember to cross your charges. I cannot stress that enough. So our first example, we have LiOH. So Li is lithium. OH is one of our anions. That's hydroxide. All bases will end in hydroxide. So it's always going to be something hydroxide. The next one, we have aluminum hydroxide, so we need to write the formula for it. Aluminum is Al. It has a 3+ charge. Hydroxide is OH, and it has a -1. We were to cross them. The 1 comes over here, 3 comes over to this side. So if we put them together, I have to write this on the side over here, our final formula will be Al. We don't write ones. And then we have OH that's going to need a 3. Again, OH is a group and we want to put a number on this group. So that means that our OH will be in parentheses with the 3 on the outside. So again, please review these rules as well. And again, base naming is just like ionics. So when you're going over ionics, go over the bases as well. Please study. Make sure you know your anions. And good luck on your test.